So now we've learned the basics about solids, liquids and gases, and we've got a summary table here that you can refer to in this video. We're going to look at some materials that don't really seem to quite fit, not neatly into those three categories. So I've got a piece of foam that you've probably seen every day, a bit of cardboard in most packages that you buy and move things around, and I've got a piece here called plasticine. So this one here, we'll start off with this one. What category, solid, liquid or gas, does this belong to? Is it a gas? No, you can clearly see it's not gas. It's not spreading out evenly into the classroom that I'm in right now. So it's definitely not a gas. Is it a liquid? Can I pour it? Well, not really. Is it a solid? Well, it doesn't really have a fixed shape, does it? So it's not really, doesn't have a fixed shape, not really a solid. Interesting. What about cardboard? Is it a gas? Well, again, it's not spreading out evenly into the space that we're in. I can't smell it in my nose and all things like that. So it's not a gas. Is it a liquid? Doesn't seem to flow or take the shape of the container like a liquid. So it's definitely not a liquid. Is it a solid? Well, it does have a bit of a shape, doesn't it? Does it, so maybe a fixed shape? Does it have a fixed volume? Well, it depends. Can you see through the side here where it's got that corrugated structure there? And there should be air in between each of those little bits of ripples inside. So it's like a sandwich. Does it have a fixed volume? Well, can I change its volume? If I fold it over a few times, has its volume changed? Probably not. Is it compressible? Could I compress the cardboard? Well, I can push down on it. Have you ever done this, where you've walked on a piece of cardboard and it has like a footprint where you stood, and that area you stood on is a little bit thinner than the rest? So I think it's a little bit compressible. I'm going to actually leave this question here about the cardboard up to you as the viewer. Now, if you are online, feel free to argue or present what you think in the comments down below. I think that's pretty cool. If you're a student of mine, in the next couple of weeks, you can probably give me your answer in class time. This one here we will talk about. This one here, foam. Is it a gas? Is it diffusing in the classroom right now? No, you can obviously see it's still staying together. Is it a liquid? Does it have a flowing nature? Does it fill in the shape of its container? No. So it's not a liquid either. Is it a solid though? Does it have a fixed shape? Not really. I can kind of change its shape a little bit, but with very little effort. So it's not a defined shape. Does it have a defined volume though? Well, I could kind of scrunch it up and squeeze it really hard. So does that mean it has the same volume? Don't know. Let's have a bit of a think. Is it compressible? The fact that I can squeeze it into a tighter three-dimensional space, that kind of sounds like it's compressible, doesn't it? So what's our decision going to be? Well, this is actually a mixture of materials, because the actual material that the foam is made out of is called a polymer. A polymer, you can think of it as like molecules that have really, really long chains. I like to think of them as like pasta. Have you ever made pasta before, where you put the pasta into a boiling hot pot and then it gets soft, and then when you kind of take it out and let it sit in the colander as it drips dry, it then becomes a bit sticky, yeah? Well, depending on how much stickiness there is, the starch, you can have like one big clump, like a really thick mass of pasta that you can't really get out anymore. That is very much what the bench I have here in front of me is made like. It has a lot of that stickiness, that the bonds and the attractiveness between those molecules makes it really thick and hard and heavy and dense, just like the bench top here. This is also made out of a polymer. This is a little bit different, I think. The polymer can also be given some air in between some of those fibers, those bits of spaghetti, and you can sort of make vacancies where the air pockets used to be and leave the little skin of those spaghetti strands around it to make those pockets. But these polymers, especially when they're very small, very short, they can actually be a bit flexible. So I think that the polymer bit is kind of like a solid. It has a shape, but it's flexible. And because there's holes or vacancies where the air pockets used to be, there's air inside of the foam as well. So that means when I squish it, because the polymer is flexible, it allows the air to come out of those pockets, which makes it feel like it's compressible. So it's actually a mixture, air and the polymer. The plasticine. Now, have you ever played with plasticine before? You can also think of clay. If you've played with clay before, or Play-Doh, or things like that, they're actually a mixture between some kind of liquid, a binding agent, if you will, and some sort of powder or solid. So it's actually, for Play-Doh, it's a bit of flour and a bit of water and some other things there, like food dye. So because it's a mixture, it doesn't fit neatly into each one of those categories. It's a mixture. It'll behave differently. This is also a mixture. I think its base is some kind of oil, because my fingers always feel a bit oily. You guys can find out. Look up, what is plasticine made out of? I would love to know. Let me know in class time, or type it in the comments below. With that said, let me know what you think about cardboard. What's its story?